Hello and welcome everyone. I'm really happy to have everyone here today for the fifth in our 6-session series, Day 1 and Beyond, which is taking you through a series of topics and activities related to building out on Oracle Cloud. For those of you who might be new to these events, we're hosted on Cloud Customer Connect, which is our Oracle community forums for end users. You'll see links in the chat throughout the presentation today that lead you back to those CCC forums. And if you haven't already, we invite you to create a free account, join in discussions, look for upcoming events on all kinds of topics. My name is Kenna Kettrick. I'm a program manager with the OCI go-to-market team. And today I'm joined by our Day 1 and Beyond presenters, Larry Beausoleil, Cloud Engineering Senior Enablement Manager, and Jeremy Walker, Master Principal Cloud Architect. And today we have a special guest, Rafi Shabazian, a Principal Cloud Network Architect, because today's session is focused on OCI networking. Before I hand things over to them, though, I am going to run one quick poll. Those of you who've been with us before will recognize that. Just drop that in there if you want to take a moment to answer what topics interest you. We build these sessions with you, our end users, in mind. So I always like to know what people are interested in hearing more about. And it's both these fundamental series and our weekly Thursday deep dives, which we have a few of coming up. I'll drop links for those in the chat, but just to let you know, this Thursday, just a couple of days from now, we're hosting OCI's quarterly integration webcast update with Jürgen Kress, which will give you the latest and greatest on release updates, ERP and SCM integration best practices from the A team and some Q&A. And then next week on the 23rd is OCI Data Catalog's latest innovations, which has a live demo of the data catalog service, some use cases and current capabilities, and some integration with analytics as well. So I'll drop some links for those in the chat, and I hope that you can join us for those. Our usual reminders, please feel free to use that Q&A box down at the bottom of your screen for any questions throughout the presentation today. We'll be answering those, and we'll have some time for Q&A at the end as well. And we are recording this, of course, so if you find out there are people you think might be interested in this or you want to share it later, I'll drop some links in the chat where you can find the replay and the slides and all of that afterward. All right, I think that is about enough from me. Go ahead and take it away, Larry.
Awesome, thank you, Kenna. And welcome everybody to Day 1 and Beyond. This series has been very enjoyable to have Jeremy, and now we have a specialist here with us today, Rafi, for networking. One of the things I wanted to kick off with as kind of a side tangent, we have Oracle Cloud Infrastructure certifications, and right now I just wanted to highlight that there's free training for them and free certifications. So this is something that we'll drop in the chat so everybody can grab, but we have a few certifications that you can go get the free training. There's going to be live sessions that are going to be that are on this page and launched, and something you can get your foundation certification, your architect associate. You know, these are all things that are going to help in the understanding of Oracle Cloud Infrastructure. All right, let's dive into networking. So let me pull up the slide deck here and get into today's big topic. Hope everybody's excited about networking. Jeremy, how are you feeling about networking today?
So it's funny. This is really my Achilles heel. Networking I've always been in the developer side of the house. Networking was always done for me. It wasn't until cloud that I really started paying attention to how networking works, knew what a CIDR range was. I started paying attention to what a virtual network in the cloud was even all about. So this is definitely going to be the Larry and Rafi show, and I'm going to be here learning and asking the questions that I hope everyone else is asking. Either that or I'm going to be learning some stuff myself. So that's where I'm at as far as networking goes. So I'm excited. The one point on that is, from a developer point of view, with the cloud being as integrated and as fluid as it is, as temporal as it is, networking is something that all developers should know something about, whether it's some serverless applications communicating with databases across a network, or whether it's a containerized network running on an overlay network communicating with other resources. Developers are becoming increasingly familiar, brought closer to, and requiring more knowledge of networking. So this is something that I think is beneficial to all, not just your ops team anymore.
Yeah, it's a large topic, and I think it's kind of a continuation of the talk we had about security, of how crucial it is to understand networking. Because even if you go to a cloud vendor and start building out your application, at the root of it, you have networking. You have to understand your latencies. You have to understand where the components sit. You have to understand how to design it so that you have your encryption in your tunnels using VPN and what that's going to entail using Fast Connect. But before we really dive into that topic, we have someone with us. We got Rafi here to kind of help us through this journey. Rafi, would you mind introducing yourself today?
Yeah, no, thank you, Larry. Thank you, Jeremy. Hi, team. Rafi Shabazian, and I'm a principal cloud network architect for Oracle. I've been designing in clouds for about 5 years. Prior to that, on-premise, I've helped with a lot of migrations with hybrid cloud and multi-cloud architectures. And I think we're living in a really beautiful time right now. I just want to add on to what Jeremy said with the convergence of all the services. Networking is and always has been a core component. And vice versa, right? Likewise, we see now in the cloud, network engineers and architects are also needing to learn all the various other types of services. So I think it's a beautiful time right now with as far as cloud infrastructure is concerned.
Yeah, definitely. So with that said, our agenda today is going to be some of the core components of it. So virtual cloud networking, we're going to talk about the gateways to get into your resources as they're built out. We'll talk briefly about peering and how that's defined. A little bit about VCN security. We definitely did a deep dive on security, but we're going to highlight the security functions for our virtual cloud network. And get into load balancer and Fast Connect. And these are some of the core components when it comes to building out in the cloud. We've all seen this if we've been here before on day one and beyond. This is something that we have a complete stack, but we're going to really focus in today. We're going to focus in on networking because this is the one of the building blocks. Now that we have security, now that we have access, now that we have some of the other layers, now we need to start building out the components so we can build out compute resources. And there's some services that need that networking component defined, our VCN defined, for us to utilize those other services. Some services can be built out and they're in the region, they're a region construct. So we're not as worried about what's going on with the VCN. That has a different security, different access. So this is really for our core infrastructure build out. We have a shared, security and compliance model that we want to discuss. And this is something when it comes to the infrastructure, what layer do you actually have to worry about? And this is where you start building out your network, your data center inside of Oracle Cloud. And we make it easy for you. We make it as simple as clicking a couple buttons and you have your site arranged so you can start deploying your resources. All right. So Rafi, we have some topics here. We got VCN, we got Fast Connect, load balancing, service gateway, hybrid, and DNS. And Jeremy's kind of learning this. Where should we start today? What are some of the things that we would want to help Jeremy out when he's building out a network? And Jeremy, feel free to chime in with questions there of what you're looking to learn when we're building out a new network for an application that you want to deploy.
Yeah, no, thank you, Larry. So essentially, I think just like with any other environment that you're going to provision, the basic building blocks, as you suggested, we're probably going to start out with the VCN, the virtual private network that gets built within the cloud infrastructure, which then you get to further define your subnets and so on and so forth. Once you start building out your VCN, your subnets, and your route tables and components, then we can start talking about how do we want to integrate this with, let's say, your on-premise data centers through the various types of connectivity options, such as Fast Connect or IPsec tunnels. And further to that, we can start leveraging the additional services for high availability, for scalability, such as load balancing, and also be able to provide that private connectivity to cloud native services using service gateways, for example. There are a lot of integrations that are hybrid of nature, meaning data center to cloud and vice versa. So a lot of communication going back and forth. And of course, right, all of this can't be done without DNS. So the basic building blocks should start with the VCN, and then we start building upon it. Upon this, in a cloud environment, typically things are modular, and so it's very easy to introduce or pivot our way around with the networking constructs within any region or any cloud provider for that matter.
Yeah, and Rafi, you mentioned something right there at the end that is interesting to me, and a lot of companies and customers that we have starting out in this. When I'm building a data center, I know how many racks I'm going to have. I know what wires and switches I'm going to have. Now I have to purchase them and implement them. And then if I need to upgrade, need to scale, need to change, I have to go and do another requisition order. How much do I need to know on day one in order to get started and start planning out? And where I'm coming from is, as an application developer, I know I can iterate and scale as I go. Do I have those same options in the network as well?
Yeah, absolutely. So that's a really good question, Jeremy. So with networking, essentially, you get to define CIDRs, for example, for your VCNs, and upon those CIDRs, you get to build your subnets. CIDRs can be scaled in or scaled out, fortunately. So if you happen to design an IP address space that doesn't fit your needs, you could always expand it or reduce it for whatever purpose. You can add additional CIDRs on to your VCNs as well these days. So a general understanding, you probably need to have a view of what it is your applications you want to deploy, whether they're databases, web servers, the different types of connectivity models. And based on that, you can start creating your subnets and your route tables. It's very easy, once again, to pivot from subnets that share, for example, a common route table to subnets that have their own independent route tables. A lot of this stuff you can easily maneuver, I would say, far more seamlessly than you would on-prem.
Yeah, that's a great point to bring up, Rafi. How easy it is to add CIDR ranges, how you expand this, you can tear this down. At the end of the day in cloud, if you don't like what you built, you can destroy it pretty quickly and remake it. So we have a design here of a VCN, so virtual cloud network. We have our availability domain here inside of our region, and this is just the start. So we have our VCN and the CIDR range you were talking about there, Rafi. Are we talking about like a nice dry CIDR, or are we talking? Oh wait, that's not the right CIDR? We're talking about network CIDR ranges here. What's the network CIDR range that we can actually utilize in our VCN? Because I know that there's a top limit and a bottom limit for it.
Yeah, I believe the top limit is /16, and the bottom limit, if I'm not mistaken, was a /28. So ultimately, these again can be resized. We can introduce new CIDRs. So, for example, if we provisioned a VCN with a primary CIDR of 10.00/16. And we happen to run out of address space, then we could add a second CIDR, 10.100/16, and we could start building our compute resources or leveraging other, cloud native services that happen to require IP address space. So overall, yes, it's we can expand. We can actually even create multiple VCNs that can have overlapping CIDRs. However, they obviously cannot communicate back to each other, but it is possible to even have overlapping CIDRs as long as they're operating independently from one another.
And that's that scaling or expanding. Do I need to know how to do CIDR calculation to quickly deploy this, or is this something that if I was brand new to this, I could hop in and build a generic VCN with a basic CIDR range?
So it would require a little bit of knowledge on how CIDRs are done, how to properly utilize them. In the day and age we live in, it becomes very easy for us to consume. So I think a lot of that planning and communication, right, not just with the network team, but with the app developers, with DevOps, so on and so forth, need to be discussed up front. However, once the team has made their decisions, you can have a pretty good template of what your CIDR ranges could be region-wide. And again, I've been in situations where we've overdeveloped CIDR ranges, and that's not necessarily a bad thing. It's just we provisioned far too many IPs than we could consume. And I've been in situations where we underdeveloped. But again, what it really boils down to with the cloud, unlike on-prem, is the ability to be agile, right? To be able to scale, pivot, and not have to worry about too many consequences during that pivot.
Yeah, and there's when we talked about like our operation course and Terraform, when you're describing like once you define your CIDR range, you can really make this easy to build and destroy your environment very quickly, especially if you need to make a change to the CIDR. But there are some changes inside of the VCN. So when you're in the console, I can change this portion of my network, but I can't change this side of it. So I would keep the same, 10.0.0.0, but I can change this portion from a 16. Maybe I want to drop it down to a /24, depending on how many resources are inside of that VCN. And then you were also saying that we can actually add multiple CIDR ranges, so we can expand. And we can also have an IPv6 CIDR range that we add to this. So we can really expand to make sure that we're meeting the needs of how our application is going to utilize the network, how we want to build out our network. We can have the multiple VCNs. But let's talk about how we actually connect into our VCN. So this is something that when we talk about communication to the internet, this is not a requirement that you have to have this component. You don't have to have an internet gateway on your VCN to be able to utilize it. So this is something that as we look at different architectures, I've worked with customers that don't have an internet gateway because they're just using the cloud as a way to scale or expand and doing data analysis. And so they don't want communication to the internet in that VCN. They want to actually map that back to on-prem. But Rafi, this internet gateway, what is it doing for me? Do I have to have multiple for my VCN, or is this something that, it's a one and done situation for each VCN?
It's pretty much a one and done situation for each VCN. The internet gateway is going to provide the path to and from the internet. So for example, let's say within the VCN, we have a public CIDR. So we have two different types of subnets that we could provision, a public subnet and a private subnet. Typically, the internet gateway is going to be used for routing to and from a public subnet towards the internet. So for example, if you had, let's say, some web servers in the public subnet and you had customers that needed to access the portal within that public subnet, well, you would provision some compute hosts within the public subnet, which would receive a public IP address, and the public subnet would have its own route table, which we would basically direct the default route towards this IGW, the internet gateway. Once that occurs, traffic from the internet can come in to the public IP for that compute instance provisioned in the public subnet, and likewise the public IP, the server on the public subnet, can access various internet-facing websites through the IGW.
Jeremy, any follow-up questions on that?
Yeah, so and I'm thinking about this, and it's kind of leading up to our next step, but it's a question that a lot of our customers have is, if I have a Palo Alto for packet sniffing, or if I have some NetScalers, something like that, can I still utilize those technologies for managing this type of traffic going in, going out, proxies of that nature? That's kind of leading to what we're going to, but that is something that pops up during this conversation.
No, absolutely, Jeremy. That's a really good question. So yes, that is something we absolutely support. So for example, if within that public subnet, you decided to provision a pair of Palo Altos, and essentially what you could do is assign the public IP addresses to the Palo Altos. And if you needed to perform a destination net, let's say towards a server in a private subnet, that can easily be done. And that way you could have your proxy, your filtering, right? Any kind of vulnerability protection profiles, right? The anti-spyware profiles, any kind of security feature that the Palos or any other kind of firewall offers can be leveraged with that as well.
Awesome. And then the follow-up to that is, so if I have instances or machines or applications or databases specifically that need access to the internet for patching or what have you, I don't want them exposed. So what are my options to protect those resources?
Certainly. So in that case, what we would do is to deploy those resources in a private subnet. The private subnets would also have a route table associated with it. Within that route table, what we'd want to do is a quad zero, a default route. We want to point it towards the Palo Alto as it egresses. And what could happen there is on the Palo Alto, essentially we could do natting, and that way we could NAT towards the internet for any type of traffic that needs to access the internet. And likewise, typically your web servers, you could put them in a private subnet as well. And as traffic comes in through the internet, through your Palo Alto, we could perform a destination NAT towards your web servers, which are in a private subnet. So all of your resources, whether they're web servers, database servers, or just compute instances, can all be protected, fronted by a layer 7 security device, third party.
Yeah, awesome. And this being OCI and being a full featured platform, we have managed services that can help you with that as well. So we have the NAT gateway, and I believe we're also going to speak about load balancers that can also separate that traffic as well. That's fully managed. So if you have like you mentioned, if we have your vendor supported solutions like Palo Alto, which is a partner of OCI, fully supported, you can also give that over to OCI to manage and just use it as a service, use NAT as a service or ingress as a service, so to speak.
Yeah, absolutely. So NAT can be used for private subnets if you did not want any kind of inbound service from the internet towards systems within a private subnet. However, the private subnet instances did need to access the internet. You could simply deploy a NAT gateway, which is similar to an internet gateway. The NAT gateway works with private subnets and provides egress only access, whereas the internet gateway is specifically for public subnets, and we could access the internet from OCI or access OCI from the internet with the public subnet via an IGW.
So now that we have some of these components, we got our internet gateway that you're talking about, Rafi, and we got our NAT gateway here. And Jeremy, thanks for bringing up that point about using firewalls, because I see that all the time where customers have a DMZ or a central VCN that they're starting and sending traffic back and forth through so that they can inspect it. You can start getting into your intrusion detection systems, whatever you need to really make sure that your environment is secure, the traffic's flowing in the correct direction. And so we have those capabilities. So now that we have our internet gateway, our NAT gateway, this portion here, we want to communicate with on-prem. And so the next piece that we can add to this is a DRG. So this is our dynamic routing gateway that's going to allow us to connect to our on-prem. So if we want to use an IPsec VPN tunnel, or if we want to use Fast Connect for private or dedicated connectivity, we can set up our DRG. Now I know that there's some new features when it comes to the DRG. Rafi, are you able to expand on some of the capabilities of the DRG? Why this is a crucial component when we start building out where our networking layer?
Yeah, absolutely, Larry. So the DRG essentially is it's a logical construct, and it's essentially the back end are two physical routers. So we do provide redundancy from that aspect when it comes to the DRG. DRG, as we can see, is primarily going to be used for terminating IPsec connections that are traversing across the internet, or Fast Connect, which are dedicated private circuits. Low latency, typically, highly reliable for different types of workloads, replication, so on and so forth. So essentially, the DRG now terminates. It sits, in front of the VCN, and we have two different ways to exchange routes with the DRG, both for IPsec and Fast Connect. So for IPsec, VPN, and Fast Connect, we support BGP, and through those BGP exchanges, we get to exchange CIDRs from on-prem to OCI. And once that connectivity is established, considering security lists are open, and the route tables have been updated for the VCN, then connectivity simply starts working. Now, IPsec, you can also support static routing. And, while we do support it, we try not to advertise that simply because, that there is no real resiliency with static routing. It takes a lot more effort, where BGP is dynamic. It's perfectly capable of handling disaster scenarios, failover scenarios. So we would prefer BGP be used for either one of the connectivity options, but IPsec VPN does support static routing as well as policy-based routing. As far as the new DRG enhancements, we now support multiple route tables within the DRG. And this is significant because previously we could only attach one VCN to a DRG. These days, we can now attach up to 300 VCNs to the DRG. And if you could imagine, if you had 300 VCNs attached to a DRG, all those VCNs have different CIDRs. And what if you didn't want all those CIDRs to talk to each other, but you needed all of them to talk to on-premise, for example? So for example, you have a prod CIDR, you have a dev CIDR, you have a QA CIDR. On-premise needs to access all of them. However, those VCNs do not need to access each other. Well, we introduced DRG route tables as well. And we could terminate these VCNs into their own independent DRG route tables now, and we can explicitly define which CIDRs we want to import by using import distribution lists. So very scalable. It's a repeatable pattern that we could do, highly effective, and it eliminates a lot of security concerns simply because you can have prod and non-prod and dev and QA all share the same DRG without having to talk to each other. There's no way for them to communicate with each other. So very cool technology. We have a lot of customers leveraging it now. So really good times.
Yeah, and Rafi, I'm working with a customer right now that's taking advantage of it, and you're right, it is huge. It makes it so that, one, you don't have to go through all the trouble to do all of these fast connects just to get access back on-prem. You can share that across VCNs. What I like from the developer standpoint is what you said kind of initially on, you can have, let's say, 3 VCNs, VCN A, B, and C. You want A to be able to talk to B and C, but you don't necessarily want B and C to talk to each other. You can manage that all through the DRG route tables that you mentioned, so that you can have shared connections. You can have your shared services VCN, which is a model for your application deployments across multiple VCNs. Your DNS sharing, if you have that capability. All these other centralized services can now be shared, but not necessarily poke holes in your security layer, your security platform, just because you need network access to a certain service or a certain endpoint. So it's huge from me as a developer, as an application developer, as an architect, to be able to have that control and not be driving my security or network team crazy, constantly asking for all of these exceptions simply because I need access to something. So that's something that I'm excited about.
Jeremy, you nailed it, right? Especially with that shared VCN, you could have DNS servers, Active Directory, you could have pipeline kits, Jenkins, so on and so forth. All of that could be in like a core VCN, for example, attached to the DRG, which can have access to all your other VCNs. And it really makes manageability and just scalability, right? Especially when from a DevOps perspective, just pushing things out there simplifies things. One other thing I just want to make a quick note on is earlier we talked about Palo Alto's and how we could use it for ingress and egress. We could still leverage the customer data center connectivity via IPsec VPN or Fast Connect through the DRG and make sure that traffic pumps, ingresses in through that Palo Alto before it hits any VCN as well. So even though we have Fast Connect, even though we have IPsec that terminate on the DRG, we could still funnel that traffic through a Palo Alto before it actually hits the destination. So that use case is very valid, whether it's from a customer connectivity point of view, from the data center, or from the internet.
All righty. So we still have one more gateway that we need to open up here. So we have our internet gateway, our NAT gateway, our dynamic routing gateway. we still need to be able to communicate to services that are inside of Oracle Cloud. And some of those services, we may not want to traverse the public internet or send that traffic back out the NAT gateway or the internet gateway. And this is the next component. So we can add a service gateway to our VCN, so we can route our private subnet, or even from on-prem going through the central VCN, we can route traffic to our service gateway, and that can be to object storage, specifically when we define the route configuration, or that can actually be to the region level services, basically. So Rafi, how's this help us when we're defining our network?
This is great. So from a VCN perspective, when we're talking about access to these types of services from the cloud, it lets us leverage our OCI backbone. So these services are hosted within our region. We leverage the service gateway, which is a very simple thing to configure, similar to the NAT gateway and the IGW, the internet gateway. There's a third option, the service gateway. And essentially, you create the service gateway, Larry, just like you said, either for object storage or all the regional services. And we modify the VCN's route tables for either the default route table, or if we've happened to segregated the subnets into different route tables, to point to these services via the service gateway. So it simplifies things. It's a very easy thing to configure. And also, we can extend this to on-prem, to the customer data center as well. So for example, if we wanted to leverage our Fast Connect to use, let's say, object storage, which is a publicly available service, through our Fast Connect, our private dedicated link, that can be done as well. It takes a little bit of configuration between the service gateway route table and the DRG route table. However, once those two route tables know how to point to each other or get to each other, these routes get advertised to your on-premise data center as well. So instead of using the internet to hit object storage, you can now start using our Fast Connect circuit to reach object storage.
That's going to be very beneficial as you start building out. So we're going to progress into the VCN security portion, because I think this is another crucial component. I know we talked about in our security talk, and Jeremy and I probably both remember this. We had another individual on the talk. We had Johannes helping us out with security, and security on our VCN. We have a couple options. We highlighted the fact that we can use Palo Alto, so we can use third-party vendors and deploy a Palo Alto, maybe FortiGate, some of those applications as virtual appliances inside of our VCN for security. We also have our security lists and our network security groups. And these components are going to sit security list at the subnet level, and then we have our network security group that's going to apply to the VNIC or the resource. And we have two main things here. So we have a stateful or stateless option. And so our stateful option, Rafi, can you describe to me like which one's better? Because I always lean towards, stateful is great, but it does have that caching portion of information. And so is it better use stateful over stateless, or when would I use one over the other?
So that's a good question. So typically stateful, when we talk about stateful versus stateless, the first thing that comes to mind are TCP and UDP for me. And so for the most part, we generally use stateful security policies. And the reason why is because, the TCP handshake establishes and that state remains active, and it makes it a little bit more easier to manage these security lists. So however, if you could certainly do stateless, the thing to keep in mind with stateless is these are bidirectional, which means there's an ingress security list and an egress security list. So if you were to use stateful for, say, ingress coming in, like in the example, quad zeros TCP for destination port 80, you don't necessarily need to have an egress security list associated with it because the state is maintained. If this was stateless, then we would explicitly have to define a stateless egress as well. And that becomes a little bit more harder and cumbersome to manage. However, I'm sure there are valid use cases for stateless, but for the most part, stateful, A lot of the applications are TCP. The one thing to keep in mind is typically when a security list gets deployed, the default egress is quad zeros for all protocols. So that's built in by default just to make things a little bit more seamless and straightforward. However, there are a couple things to keep in mind as well from the ingress perspective, such as one big thing that comes up is pings. So for example, on our ingress for ICMP, we don't necessarily allow echo requests to come through for security reasons. And typically that's something that the customer has to do, is explicitly define an ingress for ICMP type 8, and then pings can start working. Overall, they're both very useful. I would say stateful is probably, in my opinion, the better way to go.
I think the only time I've seen it when I've worked with customers is when they have to lock it down for compliance reasons. So if they're using PCI or some of the compliance, those have a tendency to require stateless because you need to track the ingress and egress for those applications. But yes, I completely, like, you know, if you can use stateful, it's fantastic. It makes your life easier, because then you have certain applications that you start getting into these high ports that you're like, well, it comes in on port 80, but where's it sending it out? So you have to know what port it's sending the traffic out and make sure that that's defined in your list, and get very complicated very quickly.
Yeah.
Sorry,
Larry,
go ahead, Jeremy. Yeah.
No, I was going to say that's exactly my thing, was the complication. One thing with OCI that I was pleasantly surprised to see was how, compared to other cloud providers, in the way that they set their stateful and stateless firewall setup. The way OCI sets it up is the way it's integrated within the same security list, the way it's laid out. You don't get quite as many gotchas as I tended to get developing on other platforms. It seems to be better laid out, as long as you're understanding, like you both were saying, what it's doing, what the purpose of the filtering is doing. Then you can see it all in one place and you see the behavior. I know in before, where if it's all separated out, you have different separating factors, different types of firewalls. A lot of times you'll be chasing down a connectivity issue for an embarrassingly long amount of time, when it was because you had a stateless connection on a port that you thought was stateful or didn't even know existed.
And Jeremy, for that, like we do have a tool that's actually for our VCNs to check. It's called VCN Flow Log, so you can actually see what communication is happening to help you really troubleshoot that issue. So exactly. it makes that easier to know, is this a security list that's blocking me, or is what's going on here? Because I've run into that issue before. Using tools like Wireshark, like doing that, basically packet capture between resources to determine what's going on here. And that can get very complicated, like you said, very complicated very quickly, especially when you start getting into multiple VCNs. And Rafi, you said, we can have 300 VCNs connected to our DRG with multiple route tables. I mean, that network alone, it's going to get very complicated in this. So it's something that I'm going to show something in the console that kind of gives you a visualization of your network, and then you can start going through that process of breaking it down a little bit easier. But last thing I wanted to, go for it.
No, I was going to say, there was a question before we move off of this too much about geographically dispersed VCN connections. Rafi, I know this is something that a lot of customers have, as far as they're following the sun support, or they have a different regional network set up across the OCI landscape. What are some best practices to use for distributing communication, making sure it's redundant, secure across geographically dispersed networks?
So, Jeremy, if I may, I just a little bit of clarity on that. So, are we talking a scenario where we want to load balance, for example, between, say, Phoenix and Ashburn real time at the same time? Or, for example, primary region is in Phoenix, and if something were to happen, how do we fail over to Ashburn? Or is this more of a region to region connectivity option? So, for example, VCNs in Phoenix only need to communicate with VCNs in Ashburn. And the reason why I bring up, a variety of scenarios is the solution is going to be different for each one, right? Let's say if you wanted to run active regions, right? So a lot of the times there's load balancing that comes into play. There's acceleration that comes into play, so on and so forth, right? Traffic steering policies and things like that. And the same with an active region versus a passive region. If we wanted to fail over, right, there's a lot of stuff that has to happen with not just routing, but DNS as well. So DNS becomes a core central focal point here. However, if we're talking strictly between VCNs, let's say a replication needs to happen from Phoenix to Ashburn, we can link those two regions up by way of RPC, remote peering connections. And remote peering connections, again, they terminate just like IPsec tunnels and Fast Connect, they terminate to the DRG as well. So you could terminate remote peer connections into their own route tables or into a common route table. Same concept as VCN attachments and Fast Connect attachments.
Yeah, and that kind of leads us, intentional leading us into our next topic. And the question, I believe, was concerned more about, private connection, and I'm going to even specify more if we want encrypted connection between 2 points, what we need to make sure that we have in place. Because the question would be, do we default encrypt between our regions? How does that data look going across the wire privately? It's not over the internet. Those type concerns that a customer may have.
So as far as encryption is concerned, I have to double check this, and sorry, I don't know the answer to this. If we default natively encrypt across, say, our backbone, for example. However,
we do on our backbone. So yeah, we encrypt by default on the backbone between regions. But it's something that if you're doing like a local peering, this is going to be encrypted. But if you're connecting into this on Fast Connect, that's where if you're doing a private Fast Connect, that's private to you, but that would be something that you would need to encrypt that tunnel.
Yes. Yeah, and so a lot of people, what we do is we leverage, right, IPsec tunnels across the Fast Connect, for example, and things like that. Now, one thing I know this has always been an issue, right? So in my previous life, typically what we do, at least one method of practice, is to make sure that whatever application that you're designing, you're about to deploy, initially starts off the transaction with a secure encrypted protocol, whether it's like TLS or something along those lines, SSH, SCP. So if we can natively also encrypt the protocol for the application itself before it even, right, ingresses or egresses into a line, that's very beneficial as well. So end-to-end encryption starting from the application as well.
Yeah, and that's definitely a fun conversation of talking about encryption and making sure that we do, if we need it, we have it. And we have the capability, and a lot of this stuff is encrypted by default here, but it's a matter of if that can add some latency and so basically processing overhead. So that's something that you have to consider when you start building out your network. Where is it sitting? How do you reduce some of that latency in the process? Quick thing that I wanted to pop back into before we hop into load balancers here, because we're diving. We got about 15 minutes left on this, so I want to make sure I highlight a couple of key components. So the network security group, just so everybody's aware, the network security group basically sits at the resource level. So it's the VNIC, and so that way you can actually isolate the resources inside of that subnet from each other. So if I have maybe a database tier, an app tier, a web tier, all in the same subnet, I'm able to actually create a NSG to lock those down between those resources and allow communication of what needs to be communicated. When you have a NSG and a security list applied to a resource, well, applied at the subnet and resource level. So in this case, we have stateful ingress port 80. That means that all of the resources in here will have port 80 open. Now, if I do this at the NSG and I have port 80 open for this particular resource that I've circled right here, if the security list did not have this rule here, and the NSG has port 80 open, port 80 will be open. So it's looked at as an aggregate when it's evaluating that resource and access to that resource. So that's just something to keep in mind as you're building this out. And so one of the kind of the recommendations or recommendations for NSGs is using NSGs because you can use the name of an NSG for access to other resources. So when you're scaling and expanding, you're able to just add those and add the NSG name and say, okay, the app tier can communicate with the next tier down. So that's something just to keep in mind. So, all right. Popping into load balancers before we hop into the console for a couple minutes and kind of show you where the networking components are. So Jeremy, I know you brought up load balancers earlier. What's what was the main thing that you wanted to focus on for load balancers?
Yeah, so there's several things about load balancers that have, I'll say, not frustrated me, concerned me, that I've always had questions about every time I start deploying them is certificate management in the load balancers, to the application, making sure that they're routable and knowing where they're sitting and where they're going, if that makes sense. So with the whole public-private subnet distribution, where does the load balancer sit? What is it giving access to? And how do I control that access on both sides? So those are just a laundry list of things that I'm going through my head. It was like, okay, I have an application. I need to grant access to it. I want to grant access to it securely and only to the individuals or applications that need access to those resources on the back end of it. So how do I do that, I guess, is kind of the general question.
So Jeremy, for something like that, again, so if we're looking at the diagram right over here, we want to access this resource via the internet. And typically what we would do is deploy a load balancer in the public subnet. Now, this public subnet will have a security list associated with it, and so on and so forth. So we could define the security of what we want to allow in from that perspective. Now, the load balancer itself is made up of two components, a listener and a backend set. The listener is going to be what the internet-facing traffic is going to make its query on. So, for example, if we're listening on 443 TCP or SSL, then right from a web browser perspective, we would simply type in https:// and whatever the FQDN happens to be. Once that hits the listener then, which is a part of the load balancer, will say who is a part of my backend set. And we'll start forwarding the traffic to the backend set, assuming the backend set is healthy, it's passed its health checks, and the backend set's port is up and running, listening on the correct port. So we have two different types of load balancers these days. So we have an application load balancer and a network load balancer. The application load balancer typically is where we can also provide additional layers of security. We could terminate SSL on the application load balancer. We could provide different types of cipher suites, so on and so forth, so it operates at layer 7. The network load balancer, on the other hand, is more designed to handle many more sessions, many more flows, and the network load balancer also preserves the source IP address of the incoming traffic, whereas the application load balancer acts more like a proxy. So different types of load balancers, different types of use cases. Application load balancers, typically we see right fronting web applications and things along those lines. Network load balancers typically would front, let's say, a Palo Alto firewalls that can scale from east to west horizontally.
Also, so in one thing you answered the question that I was about to ask, which was why would I use one over the other? That makes a ton of sense. The other one is, with us being in cloud, one of the things that concerns me and a lot of customers is, that public access to the internet, for the public cloud aspect of it. What are some things built into our load balancer, OCI's load balancer, that will protect my resources from things like DDoS or packet overloads, buffer overloads, SQL injection, things like that?
So from an application load balancer, so there are additional features we could overlay on top of this, such as WAF and things like that. And we could certainly, introduce any kind of attack types into the WAF before it actually gets fronted to the load balancer itself, and the packets start making it towards our backend sets.
Awesome. And with it being a managed service, it's going to absorb a lot of that without me having to do anything. The platform's going to take care of that accelerated traffic, and then we even have some network layers on the outside of that. OCI does to filter some of that as well on my behalf as the customer.
Yes.
Awesome.
All right. So we're going to briefly highlight Fast Connect because Fast Connect can be, it's a very deep topic, and this can go into some other conversations, but just briefly, the split here is we have Fast Connect private and Fast Connect public. And Rafi, what's the difference between private and public Fast Connect, and when am I using those?
So typically for private Fast Connect, you're going to access your private VCNs by their private IP addresses primarily. So also with public, right, as we can see the use case right at the top, it's to access OCI's public service offerings as well. So we have, again, many different types of service offerings that are using publicly routable address space. And we could carry that entire address space through the BGP session towards our on-premise data centers. So, again, if you want to access all the public service offerings, you could provision a public Fast Connect, which the only one thing to keep in mind is you are going to receive, right, that region's CIDRs for everything. And so we also have CIDR lists, JSON format CIDR lists, which you could further do any kind of inbound filtering if needed. And again, for private, typically it's to access your private resources that's within the VCN by their private IPs. However, earlier we talked about you could then create your service gateways, and if you did create your service gateways on a private Fast Connect and had the DRG and the service gateways routable to each other, then you would start receiving your, such as object storage through your private Fast Connect as well. So we've done both. Sorry, I think the screen stopped sharing, but
Yep, I did. Yeah.
Perfect. Yeah, typically the difference is going to be, privately routable address spaces versus publicly routable address spaces, so on and so forth.
Yeah, so it's something that when you start getting into Fast Connect, you can build out redundancies. So I've seen customers do where they have a Fast Connect and then they have a failover to a VPN tunnel. There's a fair amount of ways that you can actually kind of set that up for routing. For the last couple minutes here, so we might run a couple minutes long. So just kind of keep with us for a little bit because I want to show a couple of things about networking inside of the console. And I know we have a couple of questions in the Q&A that I wanted to get to. So networking in the navigation tree is this portion here. So when you go into the console, you log in and drop down to the networking tab. You have your overview, and if I click this is going to take me to a page that has all of these on the left-hand side. So we have where we can create our VCN, we have our load balancer, network visualizer, and this is the piece that I wanted to highlight when we're talking about making it easy for troubleshooting, kind of figure out what's going on in the account. So if I actually look at the network visualizer and click child compartments, I can see what's going on inside of these. So if I click here, this will tell me what's happening. So this is a VCN that I created, and I can go to VCN map, and I can drill down to all the components that are connected to it. And I know that there's new things that are going to be coming out for this with what this is capable of doing right now. So I can see I have a DRG that's connected to this VCN. I have an internet gateway. I have my service gateway. I have my NAT gateway, and it shows you, what's happening here, connection information, persistent route information, and I can drop into this, and then this will give me the OSID for that particular resource. So this is a really good tool to kind of see what's happening inside of this VCN. So this VCN test, what region I'm in, all of the components. Now this is not going to put your compute resources. This is strictly for looking at the networking layer of what's happening here. So when we want to create a VCN, This is really quick and easy to actually create a VCN. So we have a wizard here. I was just thinking in my mind that, Gandalf the Grey pops in and is like, all right, I'm going to take you through this journey of creating a VCN. And in our VCN, this will give you all of the core components. This is going to build it out as a regional subnet. So our subnets we can do here is a regional subnet or an AD, availability domain specific subnet. And this also checks, do we have a quota policy maybe that's telling us, no, we can't do this? Or do we even have, enough availability to launch that VCN? We may need to go increase the limit. So there's a soft limit in the account. So I'm going to call this live demo. And our networking component, we can create separate compartments. So kind of going back to some of the stuff when we talked about compartments, we can actually adjust this. Our CIDR, so, Rafi, we talked about this, and you were saying that we need to know a little bit about networking. What are some of the things that I would want to know real quick right here? So, in this CIDR range.
Yeah, absolutely. So, for example, we're seeing the /16. So one of the first things we should understand is, what does that /16 really mean? What is it defining for us? And then further to that, how can we subnet it right further? So this is the CIDR block. And then, of course, within the CIDR block, we have to know what the CIDR notations are going to be. So a simple subnet calculator, typically there's quite a few available online. The idea here would be you have to work within bit boundaries if we want to get a little bit technical. And we have to understand where those bit boundaries start, where the bit boundaries finish, and what are acceptable parameters for those. So simply put, a /16 CIDR is going to be able to host a number of these /24 CIDRs. So we could scale out quite a bit here. And if you can't, for example, put a CIDR of a /24 and a subnet of a /16, right? So subnets have to be smaller than the actual CIDR blocks we assign to them.
Yeah, that's definitely good to know. And there are a lot of CIDR calculators out there that can help you and say, hey, I need this many IP addresses. So if we have a /16, it's I think 65,536 IP addresses. And then for a /24, this is 254. Thank you. And it's something that keep in mind in these CIDRs that the first two and last one are taken out of this for those particular CIDR ranges. All right, so this creates.
Yeah, Larry, actually, you bring up a good point, right? The .1 for any given subnet is the default gateway for any compute or any instance within that environment.
Yep, that's definitely good to keep in mind as you build this out. And this creates our internet gateways, our NAT gateway, service gateway. And so this is what we have for creating our VCN, and it builds out everything for us. So we do have a couple of questions, and I want to try and get to those questions real quick. We also have a poll that's popped up here. So Ken, thank you for launching that, especially since we are a little bit over time. So Rafi, I don't know if you can pop open the Q&A, but there is a question there that if you wouldn't mind reading through that, I'll kind of read it out loud while you're looking at it. So I have a customer that has multiple geographic locations connecting to their OCI tenancy DRG using IPsec VPN, but none of their individual geographic connections have redundant tunnels. What guidance can I provide this customer to provide network redundancy from their on-prem environment? So this is a deep question here.
Yeah, no, thank you, Dennis, for answering this. So I'm just going to reread this. I have a customer that has multiple geographic locations connecting to their OCI tenancy DRG using IPsec VPN. Let's see here, but none of their individual have redundant tunnels. What kind? So, Dennis, to start off with, I would bring up that second tunnel if possible. Typically, our IPsec connections offer 2 different tunnels, and those tunnels typically terminate on 2 different VPN physical equipment on our side. If we don't have that second tunnel up, or if the equipment for whatever reason can't support having two tunnels towards one IPsec connection, then certainly bring up a second IPsec tunnel. Let's establish it. I would use BGP. That way we can always make sure that the routing is deterministic, meaning we don't want to have tunnel 1 and tunnel 2 have the same BGP attributes as we're advertising or we're receiving the routes. We want to make sure tunnel 1 is always tunnel 1. If tunnel 1 goes down, we fail over to tunnel 2. And if tunnel 1 comes back up, we want to fail back typically to tunnel 1, right? So to have a determined type of traffic behavior. So certainly getting the second tunnel up. Now with BGP, right, there's a lot of manipulation that can happen. Certainly you want to make sure that the routes advertised from tunnel 2 are less preferred. And you can do that on the customer premise equipment. And further to that, you can also reduce your BGP timers. So nothing that has to be done in the OCI console. Again, this is all on the customer premise equipment. So for example, typically BGP hello, hold down and hello timers, right? Or hello and hold down timers are 60 seconds, 180 seconds, depending on the vendor you're dealing with. I think that's typical for Cisco. Juniper is usually like 30 and 90. But any one of these equipment, you can reduce it down to 6 seconds and 18 seconds. That's what we support as our lowest timers, which that gives you the ability to fail over faster in the event there's an outage occurs. Dennis, hopefully that answered the question.
Thank you for diving into that, Rafi, because it's that's a huge thing to think about. Making sure you have redundant tunnels, making sure that you have failovers, all of that configured. So we do have, I know we have a really good white paper on that on our blogs that talks about the different types of tunnel setups. If you have fast connect, making sure you're routing everything from fast connect, failing over to VPN tunnels, and just having all of that redundancy built in. So, but we are past our time. Networking is a big topic. There's a lot more that I would love to cover when it comes to networking. And I know that Rafi, I, and Jeremy could probably talk for days on this particular topic of different designs and architectures. But alas, we are at an end today. So Rafi, thank you for joining us today on our networking journey in day one and beyond.
Thanks so much, Rafi.
Yeah, no, thank you guys for having me. I appreciate everybody's time. Thank you to the audience, and hopefully we can do this again.
Yeah, definitely. We'll bring you back for our networking deep dive. So our advanced networking conversation. So Kenna, thank you for having us. And any last minute things that you wanted to bring up?
No, I think we're good. This was a great session. Thank you as well from me, Rafi, for joining us. Thanks to Larry and Jeremy, as usual. We've got one more of these in 2 weeks in this particular series, and I'm excited to see where that goes. And then I would love to have you back for some networking deep dives, because there's clearly a whole lot to talk about. So thank you so much, everyone. Thanks to the audience for sticking around, and we'll see you all next time.